So I'm Jiří. I'm a solution architect and also the head of AI platform in DataSentics, which is a machine learning studio, like a biggest machine learning. We expect that we are the biggest machine learning studio in the Central Europe. We have more than 70 data scientists and about 30 to 40 data engineers. And today I'll be speaking. I will talking about building how to build a feature store and what the hell a feature store is, right? Because I guess that many of you haven't heard of this term before. Yeah, same as me 3-4 months back. So I'll give you some introduction. I'm more of a software and data engineer rather than data scientist. So if I say some wrong terms or something wrong from the view of the data scientist, please excuse me. And my colleague Vašek will join me at the end of the presentation to answer some of your advanced data science related questions. Okay, so just like briefly about DataSentics, we mostly work with enterprises, and we help enterprises to utilize machine learning and MLOps to increase sales, retention rate, decrease churn, and things like that. Besides that, we also built our own products, mostly regarding marketing. We have a personalization product to personalize communication with retail, mostly bank retail clients. We also create segments for advertising based on cookies. So those are 2 our projects. We also have a that's basically it. And as I said, we are about 100 people, more data scientists and data engineers. Not sure about how many of you have heard about something like DataLake, because in DataSentics we work mostly with DataLakes, which is this fancy new term. Data warehouses are old and all wrong. Move all your data to the data lake, which is the silver bullet, right? Not really, but they can coexist. We are working on data lakes, and on data lakes, maybe some of you knows this bronze, silver, gold terms. Bronze, as you process data from some raw data coming from the primary systems, to the silver, which is like you try to cleanse and parse and cleanse the data which comes from the primary databases, which may contain many errors, right? Some strange data formats, because there might be some very old primary systems which don't check the constraints and generate some very problematic data. And your job as a data engineer is to clean this up before you can build something meaningful on the top of it, either reports or, of course, machine learning models. So also it's worth mentioning that we are a bit different than the Avast guys, because the Avast guys, they probably use the most fanciest deep learning stuff to identify viruses and threats. In the enterprise world, in most of the cases, it's still funny that we always start with those very basic methods, regressions, and then or maybe decision trees, and then we build on the top of it. But for most of the cases, it's enough to predict that someone will buy something using these basic metrics. Okay, so in this talk, I'll focus on this part, which is the feature store, right? So as soon as you process all the data from silver to gold, and gold is this like the cleaned, everything perfect data, and then you build either reports, which is this small rectangle down there, or you can build the features to build as a foundation for your machine learning models. We also developed something like Schnitzel. We call it, which is more enterprise focused rather than Schnitzel, I guess, and we call it DIPE AI. It's a framework and also a platform, and yeah, the main difference from what we normally see in companies and enterprises is that we take the data scientists and their notebooks as the central point of the universe, right? Because in normal enterprises, the process works in a way that, okay, so there are some data scientists, they code something in a notebook, which is, yeah, some prototyping, and the notebooks is definitely the bad way of coding things. So there must be some very smart data engineer, or many of them, to productionize this prototype from notebook to some class-based, function-based, whatever complicated stuff it is. And then it can go to production. But the problem with this approach is that the original author of the solution of the prototype lose the track of what happened after, right? So he wrote some notebook, but the code now, as soon as the data engineer productionize it, the code is completely different, and the data scientists cannot iterate on the solution. They cannot go back and forth and trying to tune the final result, because it's different code, so it's complicated to improve it further. What we do is the DAPE framework is a framework to basically productionize notebooks. We develop some tooling to allow data scientists still write their code in notebook, but in a way which is like production ready. I'll show maybe later on. This is the first thing. There's also a second part. We try to help data scientists and data engineers share the same code, not to need do the like overwriting from left to right all over again. And also the DAPE framework is mostly focused on Databricks, or like Spark, right? Spark in general. We work with Databricks, AWS, EMR, or if you have on-prem Spark, it also work with your on-prem Spark. So back to the Future Store, right? So what is the Future Store, and why the hell do we need it? So yeah, some people, first time you see something like a feature store, you may think, okay, so it's just a simple client attributes table, nothing more, right? So we have some client or some basic entity. In this case, I have this table. The origin is like it's based on the delayed flights data set, right? So we have like the origin airport. Yeah, that's the airport of origin. The flights are flying from this origin airport, and they have some attributes. So in general, on average, in the last 30 days, the average delay for flights coming from this airport were like 5 hours. And there are some some percentage of delayed flights, and in contrary, some percentage of flights which came early. So this is a basic table. I have some base entity here, and like some attributes of that entity, and I can start building model on the top of it to identify, for example, maybe to predict the delay of the next flight coming from this airport, right? So this is a very simple. This is the basic understanding of a feature store. This feature store is very simple. It has only 3 columns, right? 3 features, but normally feature stores have like hundreds of thousands of features and columns for also various entities, not only customers, but also employees, cookies in terms of internet traffic, whatever. And features can be calculated using some simple ETL, but also using machine learning models. So some features are predictions. Some features are for example, the average delay per origin is like an ETL feature, right? You count number of the average delay from the existing data. So this is a attributes table. The role of the feature store in the bigger organization is basically to unify the features, right? Because in the bigger organization, you have multiple teams. You have a CRM, customer relationship management team. You may have a risk team. You may have some people from online marketing, some sales, and all those teams create some attributes of the customer. And as the number of attributes grows, you start to have problems that two people do the same thing, but maybe in a bit different way, so they end up having different numbers. So that's a good start to start thinking about a feature store, because in a feature store you have a central place where all your teams can share basically the attributes about the clients. One central place where to store features, right? So there are some like government, security, whatever stuff in enterprise, but it should help the data scientists to reuse and share existing features of their customers, for example. Is it a data catalog, right? So after some time working on a feature store or talking with data scientists about feature stores, I get into state that I thought that it's something like a data catalog for business people, because normally data catalogs are, yeah, for some data architects, some IT stuff, but business people wants to have a different view on the data and on the features. So maybe it's a data catalog for business people. It is actually, but it can give you more. So for example, so I'm a data scientist, or maybe some business guy, and I would like to understand how many people logs into my internet banking in the last 30 days, for example. So yeah, so I have some basic user interface. So which is, yeah, this is the thing we are developing, right? I haven't mentioned it, but we are developing some kind of feature store which has this tiny, simplistic, business-oriented user interface, and so we can give it to a business guy who can come and ask, okay, so I have this like feature idea, I would like to use this feature. So does the feature really exist, right? So there's search, of course, as a basic thing. Okay, so this feature exists. So how often is it calculated or recalculated? It's like hourly, daily, monthly. Yeah, of course, everyone wants to have their data updated as frequently as possible. But if there is like a lot of data, gigabytes, terabytes, whatever, it's simply not possible. It's not economically viable, right? So for some features, you can see it in the update column. For some features, daily update is good enough. For some other features, maybe even monthly update is good enough. So that's also the rule of the role of the feature store to schedule this. Yeah, who use this feature? Is this like a popular feature or not popular? Should I like use it, or maybe it's outdated or deprecated? It's being retrained regularly. If it is a machine learning feature, you may yeah, it should be updated. It should be retrained on the latest data, because otherwise it gets stale and it gets very ineffective, right? And is it performing well? So of course, the role of the data catalog can be to monitor the accuracy or the performance of the features over time. So yeah, so of course, so feature store is also a data catalog, and it can also act kind of as a pipeline orchestration tool, right? Because as I already mentioned, each feature may be updated on a different in a different interval. So the feature store needs to know how to recalculate the one feature which should be calculated right now. But for it, to be able to recalculate it, the feature store needs to know the whole pipeline. Okay, so this feature needs like those tables, and those tables needs to go through those transformations and things like that. So yeah, the feature store needs to know how to orchestrate these whole things based on some metadata, which we are also developing. And it's not a very simple thing. Yeah, this is another level of maturity of a feature store. So maybe you have a features, right? So you use Spark to calculate some features of your clients, gigabytes and gigabytes of data, but then and you store it to some like slow storages, analytical storages, analytical databases like Parquet or Delta, and then you're happy because every day you can run some dashboards, some reports, some models on it. But then some business guy came to you and asked, okay, so I would like to use those client attributes, features, in my web application, and I need like 100 or maybe 10 milliseconds response time. because it's a web application, right? You don't want to wait 5 minutes until your Spark cluster crunches all the data, and then you have a new problem to solve, because you need to somehow transfer the batch data from the slow analytical databases into some kind of a cache to be able to serve it via your API. So, and like the cache must be very very smart, right? Because you need to, from the side of the web application, you need to query. You always want to query the feature store using various conditions, and you don't know the conditions in advance. So it must be it must be capable of querying the data using those conditions very quickly as well. Yeah, you can use Elastic, for example, but we came up with a very simplistic solution, which is good enough for us for now, which is like we have a VM with a lot of RAM, and we simply put the data from Spark into this VM as a pandas data frame, in memory pandas data frame, and put an API in the front of it, and it works, right? Because the whole data frame is in RAM, and it works pretty fast. It has some limits, but for now it works even better than Elastic, which is, it's just funny. But of course, if the VM fails, you need to fill the memory again, and it may take some time, but so far it works pretty good. Okay, so how, maybe let's talk for a short time on how to move these features into production. So you create some code on your feature branch on a laptop or in Databricks, wherever you work with your Spark clusters, and then you run the code to have some the features in your development feature store to be able to look into it, maybe to if it's like a machine learning feature, AI feature, you also need to log some metrics of the features to the ML flow to be able to track your progress, right? Am I getting better in developing these features, in developing this machine learning model, or like this is the purpose of the ML flow tool, right? To lock your experiments and your models. So then, if you're happy with that, you create a pull request. That's our standard workflow. You create a pull request, and as soon as you create a pull request, there is some automated training and validation pipeline, continuous integration on GitHub Actions or Azure DevOps, which should take all your code which you wrote and try to retrain the model again, because we want to have our reproducible build. We want to make sure, be sure that the code you wrote, that you haven't changed anything before you made the final commit, right? That's the purpose of this, like, final validation, final training, which takes I don't know, like up to 1 hour, or also for some models just a few minutes. And then if it succeeds, there's also some standard code review, but this is a data task, right? So more importantly, you have to like take about data about the model. We are thinking about using this like CMLDev, which is a great tool for, maybe I'll switch to it for a second, which is a great tool to manage pull requests or to work with pull requests in GitHub or GitLab, and it inserts some data science metrics, confusion metrics, all those fancy data science stuff into your pull request for the data scientists, for the guy who checks the pull request, your model, to be able to actually decide if the model makes sense or not, right? So there are some good metrics which are automatically added to the pull request in GitHub or GitLab. So we are building this right now, and it looks very promising. So this is like the model review, and if everything is fine, then we can go to production. So the pull request, it gets merged to master, deployed code to production, so deployment finished, right? And as we are working still mostly with this like batch data. It's a batch. So for example, next day, or I don't know, in an hour, there is some scheduler which scheduled your new code, the new code which you merged and deployed, and then pushed the data or updated data in the production feature store. There's like different feature store, production in production, and also production ML flow. To be able to automate the whole process and to give some governance to it. So this is some high level overview of the process, and maybe just let's show it in a detail, right? How does it work from the bottom to the top? So someone writes some features, then there is some like technical user interface where analysts and data scientists explore the existing features, and we also have a business vertical focused UI, which is marketing. So we have some tool for campaign managers in banks to be able to personalize their emails or maybe call center calls to their clients. So let's start with the code. It's some Databricks. I hope that the cluster is still alive.
Usually, we are seeing only presentation. Should we see something else?
Still?
Yeah.
Now?
No. I think you shared maybe the tab, not the whole screen. Could you try to share it? Yes, now we do. Now we see the code.
Thank you. Mm-hmm. So yeah, so this is the basic Databricks notebook. So we have a feature definition. Sorry, this here. Yeah. So we have a feature definition here, right? So some kind of AI commuting to work, right? So we are basically predicting if people, if some client of a bank is commuting to work, driving every day on a highway from some outskirts of Prague to the work. So there are some data to use to this. So there's like a function which there's like a model loading the model from MLflow, and like putting the feature data into it, right? So the feature store, features table, right? So this is the code how we define feature in a notebook. So we have this like decorator. I'm not sure if you're familiar with that, but we have like this decorator, and there's like a feature name, some description, and some type. And as soon as we run it, it gets stored. It gets output and also stored into the feature store, which is a table. So yeah, so this data scientist create this feature, and now this feature gets automatically propagated to the web interface. Hopefully, I'll be able to find it. Yeah. So we have this simple web interface with the features, and now some guy can come here and search for the features. Also understand how often the features are updated, when they were created, what is some kind of like popularity, how often they are used, what is like business description of the feature, and things like that. So they can start using it basically as soon as they find the feature they need. Also, we are trying to draw some lineage, how the feature gets created. There's like a source table, some transformations, and the final feature. So because as soon as you have like 100 feature or 500 features, it gets messy very soon, and you need to understand how a specific feature are created. So this is like still the technical user interface, but then we have this business user interface, right? So which is like for people who are campaign managers. And this is, we call it the Persona 360 because it's a personalization tool. And so now we are trying to find some segment of our clients based on the requirements. So in this example, we would like to find people which have a great propensity to buy for a loan. So people who we think that will take a loan if we communicate with them, the odds of them getting a loan are higher than some average person, right? So this is like a PTB means propensity to buy, people who can buy, who can get a loan. So I'll choose some threshold here, this one, and then I'll just go to the next step. So okay, so now I have people who were identified by our model, that they are very propensive to buy a loan. And then I have this application will give me information for my research. Okay, so people who are the odds of them getting a loan are very high, and the other characteristics of those people, the other features of those people are those, right? So the risk of divorce is higher than normal and average. Also, it's funny that the job loss, the odds of them losing their job, or they already lost the job, and we think that they lost the job, this is like the higher odds, right? So so we may create a persona of people who we would like to give a loan by combining those features, those attributes. So for example, okay, so we would like to offer a loan to people who are who may take an investment, right? So we think that those people will buy an investment or the investment from us. So we'll just like edit as a persona as well. And we have like a smaller group. So now it's just a sample data, right? So we have like 1,000 people who are a combination of people with high propensity to buy of a loan, and also who we think that will be willing to open an investment account. And so by using this all those features, you can create a good segments of your clients, and then push it to some campaign management tool to send email to them, to call them, to prioritize them for call center calls or anything like that, right? Or you can also, on the other hand, as a campaign manager, you may think, okay, so people who are jobless, so should I give them a loan? Maybe it's a good idea. I don't know. I'm not a campaign manager, but I can also use it as a KO criteria to remove them from the group, or I can create a persona to offer them a loan, right? So it's up to the campaign manager, and that's the point of this like user interface, right? It presents all the features, all those like hardcore machine learning stuff in a more user-friendly interface for normal humans, for marketing people, campaign people. So this is like a third layer on the top of the code and the technical feature store, because that's the endpoint, right? Because mostly, as we are not only developers, but we are also consultants, and we have our products. It's very hard to sell a feature store or any technical thing to any company, but it's much easier to sell a personalization tool to a bank or to a company based on the story that you can personalize the communication based on all those features and attributes. You can model or calculate based on your data, right? So we are only able to sell the solution to business people, not to technical people, which is much harder. So that's basically what I wanted to present. So if there are any questions, I would be very happy to answer them.
Thank you a lot, Jirko. First of all, I really like Persona's visualization tool, because sometimes I find lacking a good UX design for some of our IT AI tools.
Yes.
So kudos for that it looks like really user attractive.
It's funny, right? Because we had many discussions about using about the user interface and how to actually sell the models and all the informations, all the great data and models from the backend to the end users, right? And you can have great models and perfect AI, but if you have a very crappy user interface, the people won't be able to use it, right? And it will be a disaster, and you will fail as a product. So it's not the models are great, but if your UI cannot present it in a good way, with a good user experience, it won't work simply.
So yeah, great work on that. So we have a couple of questions. We'll not take all of them because we will have some time for networking. Yeah. But the first question is Deep AI, do I pronounce it right?
Yes.
Is going to be open source, and what is the long-term goal of the platform?
So we just started in January, since January we have a team for it, 3 people, 4 people. So we are taking it seriously since January. Before that, there were many people coding something in the night, trying to build something meaningful. But since January, we have a roadmap and all those things to have a good product at the end. Some parts are open source. Very basic, the basic part of the framework. The feature store is not open source. All those things that are more complex and more closer to the business rather than an IT thing shouldn't be open source, because of course the goal of the framework is to support our products. But if someone is interested in it, we will be very happy to give it to him. We also create some documentation. We have documentation on docs.dipe.ai, and we are improving it mostly for our team. But if anyone from the outside will use it, that's great.
Okay, thanks. The next question is, have you considered any open source feature stores? What's your opinion about them?
Yeah. So we looked into some open source feature stores. We also we are also aware of some not open source feature stores which are very expensive. The thing is that there are some open source feature store from Google, and it has some features which are a bit different from us, right? Our home, our central point of universe is Databricks and Spark, so we tightly coupled it with it. As I also mentioned, we focus on notebooks, which is also very strange for some people, and which is not compatible with standard feature stores. So there are some. Most of the existing feature stores have features we don't want, we don't need, and also lack features we need. So, for example, the notebook support, the better notebook support. So that's basically why we chose to write something on our own. The feature store is not the only part of our platform. It's just like one box, one component, right?
Okay, thank you. And so what about version of the features? Do you support some time traveling to older versions of features?
That's an interesting question. So far, we discussed that, okay, so feature can be, it's a column in a table, right? So we should definitely, if we need to deprecate it, we may stop calculating it, and we can introduce some new version of it. But the column will be there, right? Because the cost of recalculating the whole table, resaving it, rewriting it, it doesn't make much business sense. We probably just leave it there and introduce a new column, new feature with a different name. That's our current strategy.
Okay, so for example, if you compute some feature by model 1, and then you decided to use model 2, you'll just add a new column, leave model 1 as it is, and work with model 2. Okay, so it's kind of like a versioning, you can say.
Feature number 1, feature version 1, feature version 2, and maybe after some time we'll kill the version 1 and just leave it blank and use only version 2.
Okay, thank you. And so probably we'll take the last question for today. So how do you handle testing when productionizing notebooks? I think it's a problem for everyone who uses notebooks.
So our notebooks are full of functions. That's the main difference. So we don't write any like zero-level code in notebooks. All our notebooks have functions. So as soon as we have as we have only functions, we can simply use a unit test or any kind of a test to test the basic function. On the other hand, we don't believe much in unit testing in the data world. Yeah, I'm a software engineer, right? I like unit tests, but not in the data world. So we mostly use data quality testing. Some monitoring of if, for example, we have some model which produces cookies to some segments, so we have some graph which monitors how many cookies is in which segment over time, and if it drops significantly, then we have some alert, but it's still a data quality testing, not a unit testing. But it's the same for our notebooks are basically files with functions, right? You can use it as a notebook, but still the user experience is the same. But at the end of the day, it's just a Python file with functions, so we can use a standard testing for it.
Okay, and maybe a question: why not create libraries? If you use it as a function, it's ready. So why not to have like some utils or something like that for that?
Well, we also have libraries, of course, but if you like to maintain or have the same user experience, development user experience as the notebooks have, that you have some code and you run it, you have this like stateful data state, and you can iterate. Okay, so I'll add a new column, rerun the cell. Okay, remove this column, maybe change the calculation a bit, rerun the column, rerun the cell. For the purpose of the user interface, we try to stick with those notebooks as long as possible. But of course, we have some standard libraries for example, a feature storage library, right? It's not completely written in notebook, but the pipelines or the models, the code, the business logic should the business logic should stay in the notebooks. The engineering code not. The code you need unit test for should go to a library, but the business logic should stay in a notebook for everyone to be able to come and see what's going on there.
Okay, cool. Because with notebooks, you always hear the different opinions. Like some people say that you should not ever use it. Some people say opposite. It's like super nice to use. It's so cool that DataSentics found their solutions to use it as user-friendly for everyone. Okay, yes. Jurka, thanks a lot for your presentation.